All right, what is poppin' party people? Welcome back to day 5 of Unit 10 in e-learning. I'll just get into it. You've got 2 warm-up problems that you'll need to get into, so go ahead and pause the video right now and try those problems out. All right, and we're back with some answers here. So for number 1, cosine of 4 pi over 3 is equal to negative 1/2. Taking the inverse cosine of that, we get 2 pi over 3. And arcsine of negative 1 is equal to negative pi over 2. Remember, in the unit circle, that gives us an undefined tangent value. All right, so 2 pi over 3 and undefined. All right, let's switch forward into some problems today. So we've been doing trig and inverse trig with a lot of our unit circle values. The thing that comes right after that is the question, what do we do if we don't have nice ratios? And we actually got a little bit into this back in Unit 8. So think back to some of the things that we did with Pythagorean triples, Pythagorean theorem. That is going to help us as we move forward in these problems. But let's try out some of those. So we have got sine of inverse cosine of 2/3. All right, we're going to focus up right here on the inverse cosine of 2/3. If I were to draw some axes for a unit circle, right, remember that when we're using inverse cosine, we're only dealing with quadrant 1 and quadrant 2, right? But because the ratio 2/3 is positive, we're looking for an angle that would give us a positive cosine value, and that's only going to happen in quadrant 1. So we can draw a triangle, a right triangle, in quadrant 1 with our angle theta. And then remember that cosine is the adjacent over the hypotenuse. So when we see the fraction 2/3, we know that our adjacent side has length 2 and our hypotenuse has length 3. Right, so now to move forward, we just, someone pick a random letter. Cool, B. Awesome. And then we can set up our Pythagorean theorem with the values that we have in this right triangle. So 2 squared plus b squared is equal to 3 squared, right? Which gives us the following. Right, and then notice once we get to this point that if we were entirely divorced from the unit circle context above, b would be equal to plus or minus root 5. Right, but when we look back at our unit circle, we see that b is a positive y value, and that means that for this context, b is just positive root 5. Right, make sure that you're keeping track of the signs depending on which quadrant you're in, but b is positive root 5. All right, so now if we want to evaluate the sine of theta, we have to recall that sine is the opposite over hypotenuse. In our triangle here, where b is equal to root 5, opposite over hypotenuse gives us root 5 over 3. All right, let's do that again on another problem here. So this time we're going to work with arctangent of negative 2/5. All right, I'm going to do the same thing. I'll set up a unit circle. But because we're working with arctangent, we're primarily looking at quadrants 1 and 4. Because negative 2/5 is negative, right? We want the quadrant where our tangent values are negative, and that's going to be in quadrant 4. So we've got theta there, and then because tangent is opposite over adjacent, we can see that our opposite side will be negative 2, and our adjacent side will be 5. All right, so again, let me get a volunteer to shout out a random letter. Cool, C, awesome. Let's rock with C. So with our Pythagorean theorem, we have that negative 2 squared plus 5 squared is equal to c squared, where negative 2 squared is 4 and 5 squared is 25, and add them together, you get 29, quick maths. All right, And then again, plus or minus 29 for C. But because we're talking about the hypotenuse of this triangle here, we are not going to use the negative. So C is just equal to root 29. All right, so now we have to evaluate the cosine of theta. And cosine, again, is adjacent over hypotenuse. So cosine of theta is our adjacent side 5 over our hypotenuse of root 29. All right, we're going to push forward. You've got 2 practice problems down here that I'm going to have you try on your own. So go ahead and pause the video and come back when you're ready. All right, and we're back with some answers here. So for example 3, remember that the inverse trig functions have very specific restricted domains and restricted ranges. So because 5/2 is outside of the domain of inverse cosine, that inverse cosine function is undefined, and you can't take the tangent of an undefined value. So altogether, we are undefined. All right, over in example 4, remember that you don't have to do Pythagorean theorem for every single triangle if you know your Pythagorean triples. So this is a 3, 4, 5 right triangle, and we can use that to bypass the entire Pythagorean theorem. All right, so let's push forward here and come on down and see what happens if we have some ratios that don't use just integers. We actually introduce a variable. All right, so let's try out example 5. Let's try out example 5. So I'm going to do the same thing that we did before. I'm going to set up some axes. All right, for arcsine, we are working in quadrants 1 or 4. But notice that x is greater than 0. So x is a positive number, 2 is a positive number. Altogether, that ratio is positive, which means that we are going to be working in quadrant 1. All right, we have our angle theta, and sine is the opposite over the hypotenuse. So you got x and 2. All right, I'm gonna get a random letter from the audience. A, cool, rocking with A. All right, and this time we are going to go back and set up the Pythagorean theorem. So we've got that a squared plus x squared is equal to 2 squared. And I'll just simplify that right quick. And we want to find what the value of a is, right? We know what the value of x is. X, I mean, we don't have an explicit value, but we know that it's x. So we want to find the value of a in terms of our other sides. So we are going to isolate that a term and then take the square root. All right, again, make sure you're keeping track of your signs, but because we are in the first quadrant, a is going to be positive and we don't need to worry about that negative. So I can get rid of this plus minus. All right, now we're going to evaluate the cosine of theta. Remember that cosine is adjacent over hypotenuse. So cosine of theta is equal to our adjacent side, which we just found was the square root of 4 minus x squared over the hypotenuse 2. All right, go ahead and try out example 6 on your own. Pause the video and come back when you're ready. All right, we're back. How'd you do? So this is the end of the notes. At this point, whatever you have left to do from your teacher's agenda, that is what you'll do for the rest of your time in pre-calc. All right, thanks for doing some math with me, folks. Have a good one. I'll see you next time.